Artificial intelligence is rapidly changing the face of warfare. Nations recognize AI as a critical component of future military strength. Wars are on the cusp of a monumental shift, driven by intelligent machines. Imagine autonomous weapon systems selecting targets without human intervention. AI promises to accelerate decision-making cycles dramatically. These capabilities could offer a decisive advantage on the battlefield. However, this revolution is not without its perils. If one side can use AI, so can its adversaries. China has emerged as a significant player in this global AI race. Artificial intelligence systems depend on three fundamental pillars: data, algorithms, and computing power. Each element is essential for an AI system to function effectively. Data serves as the lifeblood for any AI system. AI learns and improves by analyzing vast quantities of data. For military AI, data must be accurate and comprehensive. The quality and quantity of data impact AI performance. Algorithms are the brains of an AI system. They consist of rules and instructions for tasks. These models process input data. Sophisticated algorithms handle complex situations. Computing power drives the AI system. It handles massive datasets quickly. Powerful chips and robust infrastructure are vital. Without sufficient power, AI can't operate at required speed or scale. Physical infrastructure is critical and vulnerable. Understanding this trinity is key to AI in warfare. China aims to establish itself as the world leader in AI by 2030. This ambition extends deeply into its military strategy and modernization efforts. The People's Liberation Army, PLA, views AI as a transformative technology. They believe it will fundamentally alter the character of warfare. This perspective drives significant investment and research into military applications of AI. The PLA is actively working to integrate artificial intelligence across all its branches and operational domains. This strategic push is often referred to as the intelligentization of warfare. The PLA is developing AI for enhanced command and control systems, autonomous vehicles, intelligence analysis, and electronic warfare. However, this increasing reliance on sophisticated AI systems creates new and significant vulnerabilities. If these complex AI systems were to fail or be successfully manipulated during a conflict, the consequences could be catastrophic for the PLA. Chinese military strategists and researchers are acutely aware of these potential risks. They are dedicating considerable effort to studying how to protect their own AI assets from attack. Simultaneously, China is also intensely studying how to identify and exploit the AI vulnerabilities of potential adversaries. This dual-track approach is a hallmark of their strategic thinking. Understanding this offensive aspect of China's AI strategy is just as important as understanding its defensive measures. It provides a fuller picture of their ambitions. One of the primary anti-AI tactics being explored by China involves the pollution of data. AI systems, particularly those based on machine learning, are trained using large data sets. The performance and reliability of these AI systems are directly tied to the quality of this training data. If the data fed into an AI system is deliberately corrupted, manipulated, or biased, the AI's performance will inevitably suffer. Chinese military thinkers and technical publications openly discuss the concept of data poisoning or data contamination. This tactic involves surreptitiously introducing false, misleading, or noisy data into the datasets used to train or operate an enemy's AI systems. The ultimate objective is to degrade the AI's accuracy and reliability. A poisoned AI might begin to make incorrect classifications, poor decisions, or fail to perform its intended functions effectively. Detecting data pollution attacks can be exceptionally difficult. The alterations made to the data can be extremely subtle and designed to evade standard validation checks. This tactic cleverly exploits the fundamental dependence of AI systems on the integrity and quality of their input data. Beyond corrupting data, another significant approach in China's anti-AI toolkit focuses on deceiving the AI algorithms themselves. This strategy targets the way AI systems process information and make decisions. Adversarial attacks involve crafting specialized inputs to fool an AI model. These inputs are created by making tiny, almost imperceptible perturbations to legitimate data. Subtle changes can cause the AI algorithm to misclassify the input with high confidence. Chinese researchers are investing in understanding and developing these adversarial techniques. The third critical pillar supporting any AI system, computing power, also presents a prime target for anti-AI strategies. Modern artificial intelligence, especially deep learning, demands immense computational resources to process vast datasets and execute complex algorithms efficiently. Disrupting an adversary's access to this essential computing power can effectively render their AI systems useless or severely degraded. China's military strategists are actively considering various methods to attack and cripple an opponent's AI-related computing infrastructure. Cyber attacks targeting data centers that host AI models and process their data are a significant concern. Electronic warfare techniques could be employed to jam or disrupt the specialized processing units like GPUs that AI relies upon. In more escalated scenarios, physical attacks against critical computing facilities or the infrastructure that supports them, such as power grids or communication lines, are also considered viable options. If an AI system is denied access to the computing resources it needs, it simply cannot function as intended. This strategy of targeting computing power underscores the crucial physical dependencies of artificial intelligence. Despite their advanced capabilities and seemingly ethereal nature, AI systems are ultimately reliant on tangible hardware and infrastructure. Targeting these physical components is a critical element of China's evolving anti-AI thinking. The objective is to paralyze the enemy's AI-driven capabilities, thereby blunting their technological edge and creating opportunities for conventional forces to operate more effectively. China's focus on anti-AI tactics carries significant global implications. These strategies could alter the military balance of power. Western powers investing in AI may find their advantages eroded. If AI systems can be disrupted, their strategic value diminishes. This could lead to a new type of arms race. Countries would develop sophisticated AI and counter-AI capabilities. The US and allies are integrating AI into their military systems. China's anti-AI strategies challenge this paradigm. The future landscape of military conflict will inevitably be shaped by the interplay between artificial intelligence and anti-AI measures. Success in future wars will not solely depend on possessing the most advanced AI systems. It will equally hinge on the ability to make one's own AI resilient against attack, and conversely, the capacity to effectively degrade or defeat an adversary's AI capabilities. Consequently, we can anticipate a significant surge in research and development focused on creating robust AI. Future AI will need to incorporate built-in defenses and self-healing mechanisms. These systems will be designed to detect attempts at data pollution, resist adversarial attacks, and perhaps even operate in a degraded mode if their computing resources are compromised. The quest for AI resilience will become a paramount concern for military technologists and defense planners worldwide. The development of counter-AI measures is also an almost certain eventuality. As defenses against anti-AI tactics become more sophisticated, adversaries will seek new ways to overcome them. This creates a continuous cat-and-mouse cycle of innovation and adaptation. This dynamic is highly reminiscent of the long history of electronic warfare, where jamming technologies spurred the development of anti-jamming systems, which in turn led to more advanced jamming techniques. This perpetual cycle of offense and defense will likely define the AI arms race for the foreseeable future. China's strategic planning and research into methods for countering artificial intelligence on the battlefield represent a critical and transformative development in modern military affairs. These efforts clearly highlight the inherent vulnerabilities that accompany the increasing integration of AI into warfare. This is not merely a technical challenge for engineers and scientists to solve. It is a profound strategic issue with far-reaching consequences for global security, military balances, and the very nature of future conflict. The ascent of artificial intelligence in military applications is an undeniable trend, promising unprecedented capabilities and efficiencies. However, its ultimate dominance on the battlefield is not guaranteed. The demonstrated and potential ability to undermine, deceive, or disable AI systems serves as a powerful countermeasure. China, among other nations, is actively pursuing and refining these capabilities. This pursuit signals a shift in how technological superiority will be contested in the 21st century, moving beyond platforms to the intelligence that guides them. The ongoing contest between the development of AI and the evolution of anti-AI strategies will significantly shape military power dynamics. It will influence international security relationships and strategic stability for decades to come. The future battlefield will demand unprecedented levels of resilience, adaptability, and a deep, nuanced understanding of this new technological frontier.